Moving right along to the word solid, we're to I, which we call dependency injection or injection of dependencies if we want the I to really be first. This also goes by the name dependency inversion. But the problem that we're trying to address is if some class A depends on some class B, but the interface to B and implementation can change even if the functionality is otherwise stable. So how do we think about this? Well, we could have two classes that might depend on each other, but the underlying implementation can change. We'll go through some concrete examples of this, but you might think about things like an active record, the fact that an active record, we need to interact with a SQLite database and a Postgres database on Heroku, or maybe a MySQL database, heaven forbid, maybe even a MongoDB database. What we're trying to do is interface with multiple different databases that provide a consistent interface for our queries, but have underlying different implementations. The solution that we have to this is to inject an abstract interface between these classes, essentially, that both A and B can depend upon some underlying class that communicates or addresses the boundary between two implementations. And when we say depend on, we don't mean strictly in an inheritance format. Again, we're still going to compose classes together, but that we're going to use some additional class to mediate that interface. So depending on the type of interface that we have, if it's not an exact match, what you typically see are adapter or facade patterns. Or if there are sort of exact interfaces, we'll talk about the proxy pattern. But the reason we call this an inversion is that instead of some class like active record directly depending on something like a Postgres database, we invert that dependency such that both our Postgres adapter and our active record class depend on some interface that gives us a common way for those two to interact with our database. The Ruby equivalent, we often use modules to extract shared behavior, and we can include all of the methods of a module, but we'll see a few different implementations of this. So the common way to think about this, again, in the database scenario, is that, or I should say, two of the options in addition to databases are, in our Rails app, we have an interface in addition to databases for interacting with sessions, right? Temporary storage that uses typically in this class cookies, but if your storage exceeds the limit of a cookie, you might store the session data in a database like Postgres or some other database. And so in Rails, transparent most of the time to you as the developer, there's an underlying class called a session store, and that session store interacts with different kinds of session storage implementations, a cookie session store, a Postgres session store, an active record session store. And as you use your Rails or write code in your Rails app, you get to write, session username equals whatever, session error message equals whatever. But the underlying implementation uses an adapter to adapt the particular session storage to whatever mechanism you need. So typically for us, that's a cookie, but it might be a database in certain Rails apps. A couple more examples that we could work through that we might think about is you might sort of start off by writing in some view. If we're looking for VIP users in our apps, we could just write this code in a view where we write a query, we render that. We know we don't want code in our views, so we might have a method that we call in the view like user.findVIPs, but really we should think about moving this code to the controller. And this, as a version of dependency injection, is sort of the simplest way of thinking about what is the interface between the controller, which is grabbing the data, and the view, which is rendering it, and putting the dependency such that both of them directly depend on the model, but doing it in a way which, as our model adapts, we have one interface to our view, which is the controller, instead of necessarily having to adapt code in three different places. And the way to think about this is in our view, right? If we've been following strict MVC, if you've been keeping your views clean, you're hopefully implicitly already doing this, but our view now has one data object to work with, right? The @VIPs object. And if anything else changes about our model or controller, our view doesn't need to change. If we start shoving code in our views, then whenever perhaps our model changes, if our controllers change, we might need to further adapt them. And this one is a little bit smaller in example, but it sort of illustrates how being disciplined about where code lives helps us make those changes in the future. Be wary of calls to specific sort of subclasses of models, especially in your views, but also I would say elsewhere in your code that if you're querying the database directly, it is helpful to wrap those database queries in a method that declares what they are. We saw scopes earlier. It could also be an active record scope. What is the other common pattern for injecting dependencies? This is the adapter pattern. And the adapter pattern is in some ways similar to others like the strategy pattern, but again, a little bit more generic, which is, let's say we're trying to have a client that interacts with a service. That could be active record with multiple databases. That could be you needing to send emails and needing to send emails using various different email sending services. It could be interacting with not just one ticketing vendor, right? If you're a venue, you might have like Ticketmaster or something else. Or if you're a movie theater and you're dealing with selling movie tickets, you might have different movie theater APIs. The adapter pattern helps us address all of these different kinds of APIs by providing a similar interface in our application. And the idea here is that the adapter pattern, the work is to clean up, so to speak, the different types of interfaces into a consistent API that you as the programmer can use. So in Active Record, there are different kinds of adapters. All of these adapters work by ensuring that from the perspective of a programmer, right, when you write user.where, it doesn't matter how your database is structured. It doesn't matter whether it's SQLite or Postgres. User.where is going to translate that into a SQL query. The interface to the programmer is the same, but behind the scenes, the underlying logic of managing that database connection, handling authentication, whatever it might be, that will be different between Oracle, Postgres, SQLite, and so on. And this allows Active Record to handle multiple types of databases without needing to change itself every single time a new database version comes along, or whenever Postgres makes a change to their API, Active Record can seamlessly interop with that new change by using an adapter pattern without having to update every single Rails app. The adapter pattern is used pretty commonly elsewhere. If you're looking at this in our UML diagram, what you'll typically see is that we delegate methods to specific classes, and our adapters will override a consistent API. So in this case, it's pretty basic, right? Which is connect to the database, run a query, those kinds of interactions. There's a little bit more than two methods, but every adapter should provide the same interface to the API. If this is an email server that we're interacting with, right, it might be add user to email list, remove them from email list, send emails, whatever it might be. So with external services, you'll see adapter patterns pretty frequently. The other reason why this is useful to think about is if you're working with external services, those services might change on you over time. Today, you might start up with a service like MailChimp, which sends emails, and need to migrate to a service like Constant Contact, maybe for pricing reasons, maybe for security reasons. An adapter pattern allows you to, in one application, handle all those different services without having to change your underlying code. That you can have one adapter that wraps those API calls in a common interface. The other advantage here is that when you're working with external APIs, you can typically leverage someone else's work such that if it is a common and popular service, there likely already exists a gem that you can leverage for that code. So, instead of directly calling an individual API, your code would call an adapter that would do things like add a user to a list, remove them from lists, and so on. And that code would implement the MailChimp adapter, in this case, perhaps, which would then call the MailChimp API or the Constant Contact API. And if you need to swap that out, all you do is swap out the particular adapter to get to the same functionality with a different service. This becomes particularly useful as apps sort of live on and the services that you need change. Related pattern is the facade. Facades are a pretty similar pattern with the idea that what you're trying to do specifically is to simplify complicated APIs. Typically, when you work with the service, you might not need every single thing that that service provides. And so the facade pattern is specifically designed to say that what we're going to do is provide a simplified interface that gives us common functionality rather than handle everything. So some of our adapters are also facades in that they aren't intended to expose every single API endpoint, but give a consistent programming interface. In this way, right, if there are sort of half a dozen different endpoints that MailChimp might provide, our facade would essentially choose the most important ones to implement. And again, this turns out to be the case where when you're working with external services, using patterns like a facade give you the ability to adapt to services as long as you can stick with that restricted API. Of course, in practice, right, you might need to make a decision that some service implements one particular endpoint that doesn't exist elsewhere. In that case, a facade might not be appropriate for that use case. But all of these help us extract common functionality from a single class into a shared code base.